Hello, I'm Abdul Raheem, a 9-pointer from IIT Bombay. In this video, we will be solving some previous year questions from ordinary differential equations. These questions are the questions which came in the first quiz, which cover some initial topics from ordinary differential equations. I will be solving this sixth question in this video. Okay, for a solution, y of x of the IVP dy by dx plus y minus x divided by y plus x equal to 0 and y of 1 equal to 1. What is y of 0? So we have to solve this differential equation, find what the function y is, then evaluate that function at the point 0. Okay, so let me just try to solve this differential equation. So before that, I am just rewriting the differential equation. It is dy by dx plus y minus x divided by y plus x equal to 0. Okay, I can just rewrite this as dy by dx is equal to x minus y upon x plus y. And this is really obvious that this function, this differential equation is a homogeneous differential equation, because if I substitute tx and ty in place of x and y, that t will come common in the numerator and denominator and just get cancelled. Okay, so this is a homogeneous differential equation and we will solve it by substituting v equal to y by x. Okay, so dy by dx is equal to 1 minus y by x divided by 1 plus y by x. What have I actually done here? I have just divided by x on both numerator and denominator. Okay, now I will substitute v for this y by x. Okay, that means y is equal to vx. Let me just differentiate by x on both sides. So that will be dy by dx. Actually, why am I differentiating? Just to substitute here. Okay, dy by dx is equal to v into derivative of x, that is simply 1, plus x into derivative of v, that is dv by dx. So we get v into 1, that is v plus x dv by dx in the left hand side. And what is in the right hand side? It is 1 minus y by x. In place of y by x, I will just put v. Okay, so that will be 1 minus v upon 1 plus v. So we have v plus x dv by dx is equal to 1 minus v divided by 1 plus v. Okay, that is x dv by dx is equal to 1 minus v upon 1 plus v minus v. Okay, let me just carefully simplify it. 1 minus v into 1 will be again a minus v, and minus v into plus v will be minus v square divided by 1 plus v. Okay, now this can be converted into a variable separable equation very easily. Let me just take those v terms here. 1 plus v divided by 1 minus v minus v, that is minus 2v, and minus v square dv, that is equal to dx divided by x. So now this is in the form of variable separable and I can just integrate on both sides. Okay, the integral of the right hand side is just log mod x plus any constant k. Now how can we integrate this function? We have been doing this technique for a long time in this series. Suppose the numerator is some f of x, f of v, and if I differentiate this with respect to v itself, what will be the derivative? It will be simply minus 2v, right? That is actually minus 2 into 1 plus v, and we have that plus v in the numerator. Okay, if we have that minus 2 also, then it would be very easy to actually integrate this. Okay, so I will put an extra minus 2, and in order to compensate that, I will put a 1 by minus 2 outside. Okay, now what will be the integral? The integral will be minus 1 by 2 into log mod 1 minus 2v minus v square, which is equal to log mod x plus k. Now, note one thing. What is the IVP, initial value given to us? It's actually y of 1 equal to 1. Okay, here x naught value is 1 and y naught value is 1. So let's just find what will be the v value. V value will be y by x or 1 by 1, which is equal to 1. Okay, so if I substitute that 1 inside this modulus, it will be 1 minus 2 into 1 minus 1 square. It will be minus 2. It will be a negative number. So in order to incorporate that IVP, I will use mod x equal to minus x here. Okay, so we will have minus half log mod. In place of 1 minus 2v minus v square, if I remove just that modulus sign, I will have to replace everything by its negatives. So instead of minus v square, I will have v square there. Instead of minus 2v, I will have plus 2v, and instead of plus 1, I will have minus 1, and modulus sign is no more needed. Okay, that is equal to log mod x plus k. Fine. Now let me just rewrite this in the next page and continue. So we had minus 1 by 2 log mod v square plus 2v minus 1 equal to log mod x plus k. Okay. Then we can just rearrange this again. We can rearrange this into minus k is equal to log mod x plus half log mod v square plus 2 minus 1. Okay. That is minus k equal to. Now there's a half outside that logarithm which can be taken inside as power. So we will have v square plus 2v minus 1 whole raised to half, which is actually just square root of v square plus 2v minus 1. Okay, so we have log mod x plus log root v square plus 2v minus 1. Okay, I had just told that this modulus is no more necessary, but even if we put that, it's not an issue at all. Okay, so that's it. Now we have minus k is equal to log mod log a plus log b, that will be simply log ab. So I will have log mod x into root v square plus 2v minus 1. Okay, let me just take exponential on both sides. So e raised to minus k, that is some another constant. Let me just name it as m. I can put any, no issue. Now e raised to ln of anything will be exponential and logarithm are just inverse functions. So they just get cancelled, and we have x into root of v square plus 2v minus 1. But v is a term that we introduced, right? So in place of v, we will just substitute back our y by x. So we will have y square by x square plus 2v will give 2y by x and a minus 1. Okay, now let's just square on both sides. We will have m square is equal to x square into y square by x square plus 2y by x minus 1. That is m square is equal to y square plus 2xy minus x square. This is the solution of the differential equation. Now we have been given an initial value. What was the initial value? That was y of 1 equal to 1. Let me just substitute that here. So I will get m square is equal to 1 square plus 2 into 1 into 1 minus 1 square. That is 1 square and 1 square with a negative sign just get cancelled with each other, and we have a 2 here. So we have got the value of m square to be equal to 2, and so the exact solution of the IVP will be y square plus 2xy minus x square we had equal to m square, and we have found the value of m square equal to, okay, this is it. Now we have to find y of 0. Okay, let's just calculate y of 0. What is y of 0? Y of 0 is y square plus 2 into 0 into y minus 0 square equal to 2. That is y square equal to 2. That means y is equal to plus or minus root 2. Okay, so we have got y is equal to plus or minus root 2. And the correct option among them is actually root 2 and the second option, that's clear. But we actually had two possibilities, right? We actually had y as either plus root 2 or minus root 2. Even if minus root 2 was a possible answer, there was no issues because we were answering a MCQ question and we have one answer, that's enough. But I'm claiming that this y being equal to minus root 2 is not possible. Okay, but I'm waiting for you to give me a proof of that, a reason for that in the comment box. Okay, I will give a short hint. The hint is actually we have to convert this equation by adding an x square and minus x square, and that's it. That's the hint I can give. You have to modify this equation in some way by adding an x square and subtracting a x square, and that will give you a reason for why y cannot be equal to minus root 2. I'm waiting for your answers in the chat box. So by this, let me conclude this video. Thank you for watching. Follow our Instagram. Thank you for watching. Stay tuned to the channel, subscribe, and in the next videos, we will be solving the remaining questions. So stay tuned with us. Join our Telegram channel and Instagram account in order to get live updates. Thank you. Bye.